In this video, we'll be working through the question you see on the screen from the 2023 Ordinary Level Maths Leaving Cert. I recommend you try the question before watching, and if you get stuck anywhere, feel free to ask for help in the comments. I will do my best to get back to you. Check out my channel for a playlist with all the other questions. Question 4 is about functions and graphs. Specifically, part A will give you this function and we're going to have to answer questions on it. And part B is differentiation as well. We're going to differentiate a function and get the tangent of it and stuff like that. Now, apologies for my drawing because I wasn't going to go, I don't have a ruler this big, and I wasn't going to do it too exact. So I've just said roughly this goes up to 9, minus 3, plus 2. You should have this on a piece of paper yourself, probably in your exams. If not, you can pause the start of my video and see it, zoom into it, or find it online. I'm going to go ahead and answer the questions as if this is a really good drawing. So some of my numbers, I'm going to take my numbers from the real thing basically, but I'm going to show you what I'm doing and what you should be doing in the exam using this as an example. Okay, so part 1 asks you to estimate the value of G 1.5. Now, what we need to remember about functions and graphs is the x-axis is the number going in and the y-axis is the number coming out. The number goes in somewhere like this, so f of x, g of x, h of x, anything like that. What's inside these brackets is the x, that's the number going in, and the other side of the equals is the number that comes out. So in this case 1.5, and we'd go to the graph and it would be somewhere about here, 1.5, and we do it like that. We go find the line, we go up or down, and we find the line and we go across. This is the number that comes out, and looking at the graph, that looks at about 2. So the number that comes out is 2. So there's no equations here, nothing to do. We look at the graph, show the examiner this, by the way, get a pencil and a ruler, show them this, even though there's lines on the page already, show them where you've done this from, because if you do make a mistake, they'll forgive it if you did it correctly. For example, if maybe you just misread 1.5 and you thought it was 1 and you went down here and across, they'll take marks away because you made a mistake, but they'll still give you most of the marks because you did it correctly. Okay, so on to part 2. Estimate the value of x for which gx is equal to minus 6. The value. Now, here's a little clue here. It says the value of x. It might sometimes say the values of x. Now, it doesn't in this question, so I don't want to confuse you too much, but it says value, so we're only going to get one answer. Again, what goes in, what comes out. We're looking for what goes in this time. What comes out is minus 6, so I'll go to minus 6 somewhere down here. There's minus 6, and we go across this time and find where it hits the graph. In this case, it hits over here, and we go up like this. Let me just check my notes. Well, I can't see the screen too well, so I think it looks something like x is equal minus 2.75. Sorry, where I'm getting that, that's here, minus 2.75. That's what I think it looks roughly like. I had a look at the correct answers. I think they say 2.8. Close enough. The examiner does not need you to be exactly right here. They just want to see that you started at minus 6 and you got to roughly this area. They will give full marks to any student that's within a rough area of this. Okay, for part 3, they actually give you four boxes to tick. It says, how many real roots has gx? This is gx, this curve here is gx. How many real roots has it got? And you need to tick the box 0, 1, 2, or 3. The answer is 1. You need to tick the box with 1 in it, but you have to give a reason. Now, with the power of editing, that reason is it only crosses the x-axis once. So it only crosses the x-axis once. Here we go. This is what we call a root. Here, I just draw a quick example. If I had it looked like this, that would have 3 roots. 1, 2, 3. Here's a weird one. It sometimes does that. The answer there is 1 and 2, or some people say 1, 2 and 3. They're very close to each other. On the same point even sometimes. Anyway, it's how many times it crosses the x-axis is the number of roots. So this one only is 1 root, only crosses once. For part 4, let me squeeze it in up here. Part 4, it asks us to use the graph again and estimate the local maximum. Here's the max and the local minimum. And find the points. So there's going to be a point for both of these. Now, local maximum, this is a big number up here. That's not what they're talking about. A local maximum is the top of a hill. So here's a hill here. That's why it's called local and not maximum, because this is clearly bigger, but this is a local. Anywhere in the area, it's the biggest. It's bigger than this, it's bigger than this. It's only outside the area it becomes not the biggest. So you just need to get the x number and the y number here. My estimate is for the max, yes, minus 1.5 and minus 1. That looks like roughly where the hill is to me. And the minimum, again, this is a really small down here, but it's not the local minimum. The local minimum is the bottom of a valley or an upside down hill. So that'd be around about here. Again, we're trying to find the x number and the y number. And from my notes, it is 0.25 and minus 3.2. Okay, that's it for part A. Let me clear all this off and we'll do part B. Okay, for part B, we get rid of the previous function and they introduce us to a new one. We don't have to draw this one, thankfully. It's hx this time, and hx is equal to x cubed plus 2x squared minus x minus 8. And they ask us something that they will ask us pretty much every exam, to differentiate it. That's what this little dash here means. It means to differentiate. Or they say, find the derivative. So find this, which is the derivative. So this happens every year. Differentiation is one of the hardest things in maths. But don't get too panicked. What you're mostly going to be asked in ordinary level is quite simple. It's the same rule we learn all the time. How to differentiate x cubed. We take the number up here, multiply in front, take the x and take 1 away from it, so it becomes 2. So the 3 became a 2. The 3 multiplies everything in front. There was nothing there. Oh well, there's a 1, and we take 1 away, and that's it. We do the same on all of them. And the 2 multiplies by this 2, we get a 4. The x gets 1 less, so there's a 1x. We don't bother write the 1. You can. You're not going to lose any marks for putting a 1 there, but we don't have to. Gets a little trickier. We learn a couple of rules for these two, but I'm going to show you that the same rule works, and then I'll show you the one you probably know and like. So we have, this is x to the power 1. 1 multiplied by what's in front, minus 1. There's an invisible 1 here as well. We get minus 1. X, take 1 away is x to the power 0. X to the power 0 is actually 1, so it's all 1. It comes out as minus 1. There's an x here as well. There's x to the 0. There's no x's. There's no x's there. 0 multiplied by what's in front is 0. So that's how it disappears. Now what we usually say to a student is, if there's an x, it just disappears. The number that's in front of it. So there's a minus 1 in front of this x. Minus 1. Any number without an x just disappears. However you want to do it, this is the answer you should get. Without that 1 there usually. 3x squared plus 4x minus 1. Okay, it was slowly getting darker as I did that, so hopefully you can see the screen now that I put the light on. For the last part, B part 2, they asked us to find the equation of a tangent to hx. So we don't know what h looks like. Let's just say it looks like that. Equation of a tangent. We can draw a tangent. We've been drawing tangents since junior cert. But there's no pictures here. You don't have to draw a picture. We still have to find the equation of a tangent. Now, an equation, I'll put it up here, we'll use it later. Y minus y1 is equal to m times x minus x1. There's another equation of a line, but this is the one most commonly used in Ireland, so we'll stick with this one. M is the slope. Now the great thing about that is the derivative is the slope. The derivative, that's what it does. It gives us the slope of a function. And this equation gives us the slope at anywhere. This gives us many different numbers out. So if we put x as 2, let me say that again. This point here is 2, 6. X is equal to 2. If we put x equals 2 into this equation, it's going to give us the slope at this point. If I put in x equals to -1, it will give me this slope. It's amazing. That's what the derivative does. So let's go ahead and do that. We're going to put the x into this derivative because that's what it's missing. It tells us everything about x as we put in. So let's go ahead and do that. The derivative of, sorry, not x, of 2 is equal to 3 times 2 squared. Instead of x, I put a 2. Plus 4 times 2. Let's put a bracket there. Minus 1. Clean all this up. We get 2 times 2 is 4. Times 3 is 12. 4 times 2 is 8. Minus 1. And that's 20 minus 1. That's 19. So that's equal to 19. What that's really telling us is m is equal to 19. The slope at this point is 19. So now we have everything we need to do this one. We have a point, 2 and 6, that's x1 and y1, and we have a slope, it's equal to 19. So we go ahead and fill all this in. Y minus y1 is 6, is equal to m, which is 19, multiplied by x, which is x, minus x1, which is 2. Let's clean this up a bit. We get y minus 6 is equal to 19x minus 38. And then there's a few ways you can leave this. We should put these numbers together at least, but some people like to leave the y on the left. Usually in this, they haven't asked us, have they? No, sometimes they tell us how they want it, but usually we like to leave the x and the y together, and we like to leave the x as a positive. So x is already positive, 19x. Let's move the y and put it together. So we have 19x minus y. We'll move it over here. Minus 38 and minus 6 is still there. Let's get the numbers all together. So minus 38, we'll add 38 to both sides. So we'll be left with 19x minus y. 38 minus 6 is 32. And that'd be the final answer, except usually we don't leave the number on the left. 32, we put it on the right. That really doesn't change anything there. But that's your final answer. That's the equation of a line. That's the tangent to this equation. We never see it. We don't know what it looks like, but we can work out with maths exactly what it is. This tells us everything about it. And you can go ahead and draw this. And you can go ahead and draw this even. It's a bit harder. Okay, I hope that answered how to do this question. If you have any follow-ups, please let me know in the comments and I'll do my best to get back to you. Have a great day.